Y3.
Hi, we're going to present the reduction of dispatch time in the warehouse of a company dedicated to the production of chemical products. These are the team members of the project team, Rod Murrieta, Jan Andrade, John Lawrence, Samuel Medellin, and we're going to work with Kimpact SA. This is a project team of the company. So we are basically going to work with these products, Alumbre 1, Alumbre 2, Sulfato Agreso, and Sulfato Ifino, and a company located in Via Daule, kilometer 16 and a half. So first we have to go with the stratification, and we have defined our Y as only the product of Alumbre 1. And we have seen an increase in the 17.8% of the average dispatch time since December 2021. So our goal is to reduce this time. By that, we have to validate this Y, and we make a t-test with a new hypothesis of to define that the mean is 48.5 and the alternative hypothesis saying that the mean isn't 48.5. So with a d-value of 1.45, there is no sufficient evidence to conclude that the mean does not differ from 48.5 minutes and the significant level of 0.05. So we do not reject the null hypothesis, and the model is going to be adequated with using 20 replicates. So how do we do this, and how do we implement these goals? Is by implementing the 5S methodology to achieve order in the warehouse and improving the condition of the warehouse by redesigning the layout.
Okay, so now we implement for the implementation, we use the red card to reduce the tools that we don't use too much on improve the condition and order in the warehouse. Here we can see an official format for the company from Kimpact. Okay, here we can see not only the warehouse, also the office. Before we implement the 5S methodology, we can see a lot of disorder in both locations. After we apply the 5S methodology, we can see the pallets are in order, are completely, and also the workspace in the office are more organized. And the improvement of the warehouse, here we can see the official plan now. If after the improve, we can see the different racks and the products more important are at the beginning as the less are the less important, no? For the future plans. Okay, so for the triple bottom lines in the economic line, before the solution, we have a lot of overtime and dispatch are in the line that we cannot do in the same day. After the solution, we do more dispatch in the same time, so we can earn $1,000 per day approximately. Okay, from the social line, before the solution, we have a lot of overtime on the weekends and in the holiday. After the solution, we expect that we can work only 5 days at the week and 8 hours per day. Okay, so in the environment line, we can see that we can saving a lot of energy and water, expected about 6 liters per month. Okay, here we can see the economic benefits, and we've centered in the earning per dispatch per month is $48,000. And another saving is for the overtime we can save. Okay, now for the control plan, the raw causes is in the control the dispatch time and control the warehouse order. How we can react to that? If the dispatch time increase in the 10% of or a 5%.
So now we will go on with the validation in a T-student test. Here we will have the first 10 replication for a process, and yeah, we'll put them to test. And yeah, finally, we will know that our model is valid for data. So we will now go and calculate how many replications are needed with the minimum replicates method. We have the standard deviation, the error, and yeah, we will have the minimum replicates equal to 38.35. So we'll take 39, and finally we will know that we will need 41 replications for us to go and start in the bound for bounding method. These are the improvements. Improvement number 1 is the 5S. Improvement number 2 is the implementation of racks, and improvement number 3 is a mix of both 5S and racks. Next, please. As I said, we will need 41 replications. Here we can see them. Next, please. And yeah, we will go on with the bounds running method. And finally, we'll get to see the mean, the standard deviation, variance, the error, and finally, the minimum and maximum values. And as all values are positive, we know that we have a possibility to diminish the dispatch time values. The improvement tree was the best solution, and we will see that it follows a normal distribution. Here we can see the data we had. It followed a Weibull distribution. Next, please. And finally, as we get the capability analysis, we do a comparison, and we now know that improvement 3 meets the specification limits, and it has a good CP equal to 1.12. And finally, we have the reaction plan. So if something goes wrong, we can go and act and do things well.
Now we present the conclusion of the project. They are the disorder of both the batch of products inside the warehouse and the tools inside the office generate a delay of more than 14 minutes in each dispatch, which accumulate tracks in line. The implementation of the FIRES methodology made it possible to increase the efficiency of dispatch, reducing their times and generating more dispatch at the same time. And the racks allow greater control over the inventory in the warehouse, as well as control over pets and defective products. And finally, we present the recommendations. They are be more active with the workers in the control area to always know what activities they are carrying out. They continue with the TOC methodology to find again the constraint of the system and continue to improve the system. And finally, generate a culture of order and clean lines within the workers, and thus maintain the warehouse. Thank you so much.